say that artificial intelligence is a big umbrella and machine learning is a part of it, right? Strongest set of techniques under artificial intelligence, right? And these things have been there in existence from years. It has now come into IT because in IT and in the digital world, we now have huge amount of data available. And the tools to handle this data is available, like Hadoop and different big data. And uh, based on the data, it is now possible to build some intelligent algorithms, and that's where industry has started adopting it. So we'll look at a couple of examples and applications of machine learning. Where so you see the difference between the known ML and ML technique under AI is what? The techniques which make use of data, which make use of data, they come under machine learning. Which does not make use of data, they come under AI. I mean, they are also AI. This is also AI. It's just there are some other techniques which does not make use of data that come under known machine learning AI techniques. You can say, for example, you can take an example of fuzzy logic. In our washing machine, we have automated washing machine system, which is fuzzy washing machine system. That's also an AI technique. It is the same technique is also used in automatic braking of car, automatic brake lock, anti-lock door system, automatic car braking system. It is also used in missiles to tune the missiles parameters to make it successfully launch, and variety of scenario it is used, right? But there are a lot of strongest set of technique where intelligence you can build is very powerful, and that comes under machine learning. And one part of machine learning is also called as deep learning, which is, so these days, what kind of advancement you get to see, the AlphaGo from Google, right? OpenAI from Google. These all are advancements, and you can say IBM Watson. These all are backed by deep learning techniques, advanced machine learning techniques. These are self-driving cars. One of the application of self-driving car is one of the application of deep learning is more of self-driving car, right? So that is also one of application of deep learning, right? So this is the landscape of AI. Now there are a lot of relevant terms, right? For example, you might have also heard of data science. So data science is what? From years, we have been working with something called statistics and probability. Statistics and probability to understand and to interpret data. Now this is what we have been making the logical interpretation of data, and particularly particularly when you combine data science and machine learning, that becomes data analytics. This field is called as data analytics, which is quite popular. So whenever you see data analysis and data analytics, it is actually contributed by machine learning on data science and more powerful term, right? So this is a combination of data science plus machine learning. Similarly, when you combine image processing is an independent thing. When you combine image processing plus machine learning, that becomes computer vision. Right? Image processing plus machine learning, that becomes computer vision. Right. So that's all idea about particularly the landscape of artificial intelligence, in which multiple terms are quite correlated. So data analytics makes use of some AI technique, machine learning techniques, and particularly computer vision also makes use of that. Right. So there's a question so far I'm having. There are a couple of questions. One is the application of machine learning. Right. Example of that. We'll be looking at that. There's a question from Sandeep. He says that, hi, I have a query on deep learning. How deep learning uses data. Right. Yeah, deep learning, you see the way machine learning makes use of data, the similar way is there, but there is some more advancement into that. We'll be coming to that once we have the understanding of machine learning. We'll be coming to that as well. I'll take your question for sure. Right. So this is the landscape. You see, everyone. This is the structure as well, like how particularly AI and machine learning, deep learning are related. So in industry, the kind of AI that we are actually working on is mostly machine learning, right? And most of the applications which we are working, like you talk about chatbots, you talk about predictive maintenance for manufacturing units, right? You talk about in banking and finance. I have been much more attached to banking and finance, in that we work with credit card fraud detection, customer behavior analysis, supply chain analysis, and prediction of it, right? So multiple of applications are backed by machine learning because of the huge amount of data available that makes this thing go quite particularly popular and usable, right? So the question is, it's all good, but the question is, why do we need that? Right? Why do we need to implement machine learning? So let me give you a couple of examples. You see, 5 years back when we used to apply, I hope all of you majority of you are from Indian time zone, so you might be having the idea of, if you're not even from Indian time zone, probably you might have experienced 5 years back when we used to apply for loan, right? So when we used to apply for loan, every loan application was processed by humans sitting in the bank manually. It was approved or not approved by humans sitting in the bank, right? As the time went up down the line, right? So the number of customers of the bank increased because of the digitalization, right? So the way we used to apply for loan 5 or 6 years back, we used to go to the bank and fill a form manually and apply for loan. So every bank used to get limited set of applications for loan and credit card. Down the line, because of internet, because of digitalization, the number of customers the bank could get has increased like anything. And today there are around at least 1,000 people who apply for loan for a particular bank every day. Now consider there are 1,000 people who are applying for loan every day, and there are humans sitting in the bank who are analyzing the loan applications. It's very general that 800 of those 1,000 will not be eligible for the loan, right? So it's very low conversion rate you get. 800 will not be eligible, and only 200 will be eligible, and they'll be further processed. Now, if they put human resources to analyze all this 1,000 data, so you can say if 800 are not eligible, so their 80% of the workforce is filtering out only those people who are not going to generate revenue. 80% of their human workforce is going to filter only those people who are not at all going to generate revenue to the bank. So that's where the revenue model is not going to support this model. So that's where they need to use something where they can use something and build some intelligence so that their workforce work is productive. Their human resources can do efficient work, revenue generating work. So what they did is, from 5 years, they collected data, 5-6 years, they collected data of every loan application which was submitted to the bank manually. From that data, they trained a machine learning algorithm. So machine learning algorithm has now replaced the humans for that job. I mean, has not replaced, actually has worked as an assistive system. So now when we today apply for loan, right? So our loan application online is first processed and assessed by a machine learning algorithm. The algorithm takes the decision that whether we are eligible or not, and then if we are eligible, then only it is forwarded to humans for manual processing. So here is how machine learning is helping them out, the banks, to improve their work quality and efficiency. And this is now in every scenario. So you see the meaning of AI. I mean, a lot of people get scared with AI and have a lot of hopes with AI. You see, the point is that these days, the kind of adoption of artificial intelligence and machine learning that we have into industry is not something that it is replacing humans, not at all. We are developing artificial intelligence and machine learning based application to assist humans, to work under humans, right? For example, let us say that in this scenario also, the algorithm has not completely replaced human. It just is working as an assistive system so that the humans work could get more productive. Another example is, let's talk about a scenario of a doctor who is treating the cancer patient in healthcare, right? A healthcare example. So a doctor who is treating the cancer patient, now every day with the advancement in technology, the kind of data the patient used to get is improving. The patient now gets more reports about them. Probably you can say that earlier less reports were possible. Now you can do much more tests. You can get CT scan, you can get MRI scan, you can get blood test, this test, ABC test, XYZ test, PQR test, a lot of tests. That has improved a lot. And because of that, it is now possible to get more insights into the patient data. So that's a good thing. But the problem is, it has also increased the amount of data that as a doctor has to consume for particularly for every patient, right? So that's where it has improved. I mean, that has increased, right? So I'll take you another example, Shreyans. Probably it will be much clear. I'm coming to another example as well, right? So in that scenario, you see this: the doctor has to consume data for patient that has increased. For example, let's say that 5 years back, the kind of patient the doctor could deal 5 patients, 6 patients. Now that would have decreased because the amount of data that each patient will be carrying up will be high. So their doctor needs an assistive system to treat those patients. There you need machine learning to develop such an assistive system. A very basic example, probably many of you would have already experienced, is 5 years back when we used to use Ola app. Whenever we had a problem, we used to connect to Ola people, right? We used to call them, their customer care executives, and get our queries resolved. Now down the line, as the number of customers of Ola increased up, they cannot increase the number of customer care executive correspondingly, because that query solving session is not generating their revenue model, right? So what they did is they collected data of those queries which customer used to make by call, converted speech to text, and trained a chat bot, which is a machine learning application. And now today, when we have some issues, we connect to chatbot, we tell that this is the problem, a chatbot resolves our query. And the same happens with Uber, same happens with Zomato, Swiggy, and all this scenario. Now these all companies are low revenue model companies where they have low margins. And with that, they cannot have much more human resources to treat their customers. So that's where they're using machine learning based applications to particularly treat the customers. So you see, down the line, as soon as the number of customers, the complexity amount of data that is increasing, that has also created a lot of need among the industries to adopt machine learning based applications, right? So that's the basic logical idea that how machine learning is being used today, right? So the main idea of machine learning is like we're going to go ahead and talk about a little idea of machine learning, right? So main idea of machine learning is like, you see, we humans learn from experience. For example, if I have to learn to ride a bike, what I will do is I'll go to the street, ride the bike. First time, probably I might make an accident, probably I may not. If I made an accident, second time I go to ride a bike, I'll try to avoid that way through which I made an accident. If I did not make an accident, I'll try to use the same way. So we humans learn from our experiences and we try to improve our performance, right? So we humans generally learn from experiences. And currently, whatever machines that we program, the systems that we program, those machines, those systems, they follow instructions. Machines follow. For example, we design system, if this, then do this. If else system, we program the explicit rule, mathematical rules that we program. We humans decide the rule. That's how currently machines work. Machine learning is all about, the main idea of machine learning is all about making machines learn from data. Making machines learn from experiences, you can say. For them, the experience is data. Right? For them, we humans learn from experience and machine follow instructions. So machine learning is all about making machines do like us, right? So the way we do things, the way we learn things, the way we build intelligence is like, let the machines learn from experiences, let them learn from data. For them, the experience is data. That's all about logical meaning of machine learning. Right? So the applications are much more. We have seen the example of loan application, right? And there are a couple of other examples. If you simply like realize 5 years back, when we used to upload pictures on Facebook, it was like Facebook used to ask her, would you like to tag your friend? Would you like to tag your friend? We used to say, okay, let's tag. Down the line, 2 years later, Facebook started detecting our faces. Okay, this is some face. Who is that? Who is this? Who is that? Who is this? Down the line now, when you upload pictures of yours and your friends on Facebook, Facebook also knows that how do we look like. It says that this is Mr. X, would you like to tag him? This is Mr. Y, would you like to tag him? This is Mr. Z, would you like to tag him? So Facebook knows how do we look like, even our government do not know that. So down the line, from the data that we have uploaded on Facebook, the images that we have uploaded on Facebook, they have trained their model, machine learning algorithms. And that has created a lot of ease in people, interest in people to upload their pictures and tag so that multiple people can get connected, engagement, it could be increased like that. So multiple companies have started using machine learning based applications for a variety of their use cases, right? Support sectors and ticket sectors like that, and support system enhancement, the project management enhancement, the chatbots, right? And particularly customer churn analysis. Multiple examples are there where machine learning is being used. One of the example I can share, which we'll be doing throughout this course, is like this will get it more clear. Shreyans, let me know if this makes it much more clear. Right, so here we go. So let us say that we have a bank, right? So where can you use machine learning? So let's say that we have a bank, and the bank has given us a data of 10,000 customers of the bank, right? So we have 10,000 customers data of the bank, right? For every customer, we have the row number of the customer, We have the customer ID of the customer, right? We have surname of every customer. We have credit score of every customer. Let's say that we have some values like among 1,000, which shows the credit score or CIBIL score, you can say. We have geography of customer. Customer belongs to France. Customer belongs to Spain. France, Spain. Customer belongs to Germany, like that. So where the customer belongs to. We have gender of the customer, male, female, like that. Age of the customer, tenure, how many years it's been the customer is associated with the bank. 2 years, 1 year, 8 years. The minimum balance reported in the customer's bank account in last 6 months. So this is the data of last 6 months. And the minimum balance reported in the customer's bank account was this in last 6 months. The number of products the customer has. The number of products in the sense like the number of, like you can say that 1 means only savings bank account, 2 means the particularly 1 means only savings bank account, 2 means like you can say that savings bank account plus a loan or plus an insurance, plus some credit card like that. How many products the customer has from the bank? Whether customer has a credit card or not. So 1 means yes, customer is having credit card, 0 means no, customer do not have credit card. 1 means yes, customer has a credit card. Customer is an active member or not. So has customer done some significant amount of transaction in the last 6 months or not? So 1 says yes, customer has done that. 0 says no, customer has not done some significant amount of transaction in the last 6 months. Then we have estimated salary of the customer's bank account, right? So what was the expected, the estimated salary, because bank never knows the exact salary. So what was the regular amount being deposited in the customer's bank account that we have? Now the problem is what? The bank found out that in last 6 months, a lot of customers started leaving the bank. So here, this column shows that this customer left the bank. This customer did not leave the bank. This customer left the bank. This customer did not leave the bank. So in last 6 months, a lot of customers left the bank and the bank is worried. So now they come to you as a machine learning engineer. They want you to build a model from this data, algorithm, train the algorithm from this data. You can build a model which can predict based on looking at their current customers' data, who will leave the bank in next 6 months, who will leave the bank in next 2 months or 3 months or 4 months, who is more likely to leave the bank. If bank knows that in prior, if your algorithm can predict the future, that in the future this customer is likely to leave you, if bank knows that prior, bank can give them some offers so that they can retain their customers. You can also build a machine learning algorithm from this, which can also tell why that customer will leave the bank, right? And that's where bank can give only specific offer to that customer so that has to retain the customers. So this is where in the current scenario in IT and in banking, finance, healthcare, and education, in all the domains where IT world deals up and out of them, a lot of adoption of machine learning based use cases have started and has taken a big boom. Right. So I hope this makes it clear, Shirans. Let me know if it is clear, the couple of use cases of machine learning and examples of machine learning where it can be used. Right. Others, let me know if it is clear. So for any question that you have based on the current discussion that we may have. Right. So these are a couple of use cases where it is being used. Talking more about it. So here is like we have a little better in different domain wise. In manufacturing, machine learning is being used for predictive maintenance. So tell that when your plant or your machine will get damaged to predict the future. Warranty reserve estimation, how many years, like currently warranty reservation is like we have fixed warranty reservation. So it could be particularly made adaptive one. Demand forecasting, process optimization, telematics, different other domain. We talk about financial, right, credit worthiness, looking at how many stocks are moving on together, predicting the price of cryptocurrencies, blockchain engagement, return on investment analysis, right, inventory planning, right. These are a lot of other applications where machine learning has started playing a big role, and this is one of the very adaptive thing in a variety of domains, right. So that's the basic idea about the possibilities with machine learning, the applications of machine learning. Now, as a machine learning engineers, we have to do 2 jobs. One is that you need to build a learning model, a predictive model, and you have to do a lot of aggregation on data. And you have to do a lot of pre-processing on data. For example, there was a question how deep learning is different from machine learning. So you see in this scenario, when it is banking data, you can say the property of every customer in some numerical format. You can say that property of every customer is available in some numerical format. But what about if it is face detection, face recognition? Now in face recognition, how do you say numerically the value of my ear and eyes and lips and nose? You cannot numerically differentiate, or you cannot tell the exact numerical value for eyes and ears and different other features of face for car, for animals. So that's where feature, these are, you see, these every property of the customer, age of the customer, tenure, balance, number of product, active member, salary. These are different properties. Every property is called as a feature of the customer. So here in banking, finance, manufacturing, it is pretty easy to numerically define your feature. But when it comes to text, let us say it is chatbot. Now in chatbot, how do you add mathematics, right? So there it becomes very difficult to define a feature. For example, face recognition. How do you mathematically define the value of ears and eyes and nose? It becomes very difficult task. For example, it is audio transmission, audio conversion, video analytics, image analytics. These are all fields where the machine learning becomes very less powerful, you can say, and where the traditional machine learning is not much effective. And that's where deep learning comes into the picture. So deep learning does automatically feature recognition. The basic difference between machine learning and deep learning is, to a machine learning algorithm, you need to tell what to learn, right? To a machine learning algorithm, you need to tell the algorithm what to learn. A deep learning algorithm automatically finds out what to learn and how to learn. So that's where deep learning is one step ahead of machine learning. But in all the scenario, you don't use it. And for going into deep learning, you have to first start with machine learning, then only you can go ahead with the deep learning part. Directly from deep learning, you cannot start because that will not make any sense with that. Right, so that's where you need that scenario. So that's overall idea about this particular scenario, machine learning and deep learning. So in deep learning, data is aggregated. There are multiple deep learning algorithms which analyzes data and does the feature detection and then process that part. So deep learning makes use of machine learning plus something more is there, which helps in automatically recognizing what to learn. Right, so that's the idea. So far in this particular course, you will get to learn a lot of machine learning basics. Right, so in that, like you will get to learn some basics of artificial intelligence, and you'll also get a complementary Python course. Like the very popular programming languages used for machine learning are Python and R programming. But when it comes to deep learning, Python is much better than R programming. So we generally prefer Python. And in this course also, we're gonna go ahead and talk about Python only, right? So that's where Python is, because Python is become more popular and compared to R programming, right? So you will also get a complementary course to learn basics of Python programming as well. And then we'll talk about mathematical modeling, what machine learning, different algorithms we'll be looking at. So there are a bunch of algorithms to build predictive models. There are a bunch of algorithms to build descriptive, or you can say pattern recognition models. So neural networks, how does it works out? Majority of the deep learning algorithms are advancements of neural networks. So neural networks are one of the very important algorithms in machine learning. We'll be learning about supported machines, different concepts of that, and we'll get to see about image processing with OpenCV and different computer vision related application, clustering, principal component analysis, and TensorFlow. TensorFlow is one of the deep learning library supported by Google. We'll also work with recurrent neural networks, time series forecasting, and particularly convolutional neural network. We'll work on projects like customer behavior analysis on the previous data, marketing campaign analysis. We'll work on projects like predicting the price of Bitcoin for next 2 days, predicting the price of Ethereum for next 2 days, Twitter sentiment analysis, streaming live tweets from Twitter and doing the brand analysis of Donald Trump or something like that. Right, so that will do. How do we do social media analytics and use machine learning for social media? One of the projects that I was recently working on with one of the company, it was they wanted to calculate the ROI. So that's where what they were using is, let's say that there was a FMCG client. FMCG has product like you can say Coca-Cola or something like that. You can consider beverages and eatable products, right? Something like that. Okay, so they wanted to calculate the ROI, in return on investment, for the celebrities they spend money to analyze. For example, let us say that Coca-Cola is spending money on Ranveer Singh to advertise Coca-Cola. Now they want to know that how many times Ranveer Singh is spotted on social media and Coca-Cola logo is also spotted up. So we built an algorithm in which we could collect all the tweets from Twitter Right, I hope I'm not audible. I hope I'm not audible. It seems there might be some issue. No, it was not a pause. It seems there might be some issue. Right, I hope I'm not audible to all. Right. Yeah, so I was discussing about a particular use case where we were trying to collect some social media data, images and tweets, and calculate the return on investment for Coca-Cola, like how much return they are getting as an impression and social media popularity when they ask in convincing to endorse their brand, they ask some other celebrities like that. And so that's sort of applications are being built up, a lot of them. So that sort of stuff we'll be doing up. We'll be also working on some projects like building recommendation systems for like the way you can see on Amazon product recommendation, on Amazon and on Netflix movie recommendation you can see. So how do we build such a recommendation system using different other algorithms like collaborative filtering, content-based filtering? Those projects we'll be doing up. We'll be working with principal component analysis for the data dimensional reduction, right? Clustering techniques. Keras also will be running a little examples on Keras as well for deep learning applications. So these are a lot of exciting stuff that we have in this basic course on machine learning. We don't have much more about deep learning, but if you opt for this course, which is combination of machine learning plus deep learning, which is spread across 65 hours, in that you have more of machine learning algorithms like decision tree. Decision tree is widely used in financial banking. Neobase is used for text-based analysis, chatbot sentiment analysis, right? And other than that, you'll get to see work on convolutional neural network, recurrent neural networks, and NLP, natural language processing related applications, right? So those are using recurrent neural networks. We can build up time series data analysis, predicting the cryptocurrency prices and all, building chatbots, Boltzmann machines, natural language processing, sentiment analysis, semantic analysis. These are all different other exciting content that we have in this box of machine learning plus deep learning. Right? These all are part of artificial intelligence, right? So don't consider that AI is different. There are some courses you get to see there where they teach AI differently and machine learning differently, but machine learning is a part of AI, right? So you can say that it's the same thing. In fact, there are a lot of other AI techniques which are not machine learning techniques are popular, but in IT we don't use them much. So what is usable is this, is particularly this. So a lot of projects will be there. Some new projects will also be there. So this is all about the particular artificial intelligence plus machine learning course content, right? So Shreyan's IoT course we are not discussing here, but yeah, there would be some other. We are talking about IT. In IT, this is important, information technology, that IT world. And IoT course for that, there is also there would be a webinar, so you can connect to the sales team or marketing team of the company, and they'll let you know if there's some webinar coming up for IoT course, right? So you can check out that as well. Okay, so this is all about machine learning part. I hope I'm clear with this part, everyone. So let me know if you have now any question relevant to the course or relevant to anything that you will be doing. So we'll be doing completely hands-on stuff. We'll be working with Python programming. So it's gonna more of 80% of the course is gonna be hands-on part. I'll be right. So we'll be taking up a lot of programs and examples, and all the sessions that we are having. So all the videos will be recorded and it will be made available to you. So whatever live sessions we do, in every session videos will be recorded and those videos will be made available to you on LMS portal where you can access them. So for example, one day you even missed half of the session, so it won't be a big deal. You will be able to recall that from the video available to you, and which will be available to you for lifetime access. Along with that, as a prerequisite of this course, you'll get a complimentary course as a Python programming to learn Python. Okay. Okay, so Shreyans, I got an answer for you. So on 1st April, we have a course demo session on IoT. On 1st April, we have a demo on IoT. So you can just check into that. You can be a part of it. Okay. So yeah, this is all about the basic idea of artificial intelligence machine learning. So yeah, there is a question from Sandeep. The example you showed is nice, but data is structured. Consider if we have unstructured data, like yeah, in that case, then we have to work with regular expressions. So a little bit of regular expressions are mentioned into the Python course. How do we use regular expressions to handle that, right? And more than that, you can look into particularly, I mean, we'll be doing some handling and some categorization on data on unstructured. For example, we'll be doing one example of Twitter. So whenever you fetch data from internet sources, so it is generally unstructured data. So the way you handle it, there are some regular expression tools, the way you can handle it, string manipulation and scanning the pattern. And from that, we can handle the unstructured data and convert it into structured data. which is a very, very important, and you can say one of the very time-taking tasks, but that's important task, and that has to be done in real-time scenario. While learning, we can get a lot of structured data, but yes, I agree on that point. Unstructured data is also a big challenge. So we have some examples which addresses that part. Right. Generally, we use regular expressions and different other techniques to handle unstructured data, convert them into JSON format, extract keys and values. So that part we have. Right. So I hope I'm clear with this part so far. Let me know if you have any question, any doubts so far relevant to the course content, relevant to how we'll do that, and any other idea that you want to have so far. Let me know. Okay, so far I believe like this is clear to all of you. Let me know. Shreyan, Shobhan, Srinivas, and Suman, Vanishri, and we have with us Sandeep, Manoj, Nagarjuna, Mr. Gaur,